Welcome to Inside Startup Investing, the only podcast where you can invest in every guest. On this episode, I will be speaking with founder and CEO of EarthGrid, Troy Helming. EarthGrid is a tunnel boring technology company that leverages the efficiency and effectiveness of plasma technology to quite literally bore large holes in the Earth's ground to enable the burying of utilities like power lines and water pipes and the creation of tunnels for new transportation portals. A few things that stood out to me in this episode are, first off, it turns out in the United States, only 8% of our power lines are buried underground, which in the words of Troy Helming is much like living in a third world nation. Overhead power lines are known for causing fires, failing during snowstorms, and generally are ill regarded by well-established communities. So the demand for underground utilities is fast growing in the United States. The second thing that is really interesting about this technology is the fact that the next best thing that exists out there today aims to be able to bore tunnels at the speed of a snail. At that rate, our infrastructure in the United States that is already graded a C- is unlikely to get the upgrades it needs anytime soon. With EarthGrid's plasma technology, they can bore holes at a far faster and more cost-affordable rate, which can help power a new generation of utility development in our country. Lastly, the team behind EarthGrid is no joke. Troy has raised over $50 million for this business, has put his own dollars into this business, and has already published over 82 patent claims with 70 more pending for EarthGrid Technologies. And this isn't his first rodeo, as you will hear. So with that, let's get on to the show and welcome Troy. So can you tell us a little bit about EarthGrid, who you are, what is EarthGrid, for all of those who don't already know?
Sure. So I guess I'm akin to a modern day industrialist. I've been building solar farms and wind farms for about 30 years, long time, including two of the biggest solar and wind companies, respectively. And EarthGrid is a company that's going to solve our infrastructure problems. About 7.5 years ago, I invented a plasma tunnel boring robot. So imagine a little tractor with lightsabers on the front, kind of vaporizing, melting, and spalating the rock and soil really fast. It just uses electricity and air. So the idea is to put power lines underground, more transmission lines to accelerate the clean power revolution, because it takes 15 years to put a new transmission line in this country to get it permitted and built.
All right, a lot to unpack there. First off, let's back up and understand a little bit about your background and how you are the person to design this plasma boring technology, which I imagine is quite advanced. So tell me a little bit about your background and the team around you that's developing this.
Yeah, well, I have to give credit to the team because they're really the ones designing it. I came up with this crazy idea thanks to a Navy SEAL who inspired me. He was one of our solar engineers at my last company, and he was bragging to his girlfriend in a bar in San Francisco about how his Navy SEAL team used to practice entering enemy ships by going underwater, cutting through the side of the ship with a plasma cutting torch. We're all like, dude, you're such a badass. And anyway, I popped out of bed. I was like, plasma. I wonder if I could go through rock, because it's always been way too expensive and slow doing any underground civil construction work. But yeah, I mean, I think like an engineer. I went to college for nuclear engineering, actually. And then my dad's like, hey, get a business degree. You can hire engineers. So I did, and I did. But I think like one. And in my last company, I had designed and patented floating solar technologies. And so I had a little experience coming up with new designs.
In terms of the boring technology that exists out there today to dig these massive trenches and holes through the ground, what does it look like, and how is this improving on that?
Yeah, so existing technologies use mechanical force to drill through, rock and soil. So drill bits, cutter heads, tunnel boring machines like Elon's company, the boring company, and they've made some pretty clever enhancements to that tech, but it's still quite slow. They aspire to someday be as fast as a snail. Using plasma replaces mechanical force with energy. It's called energetic drilling or boring. And so we let electricity do the work that used to be done by drill bits or cutter heads and humans, as well as chemicals. All the other processes use a variety of bentonite, drilling mud, chemicals, lubricants, nasty stuff that can leach into the groundwater, and you have to pay to get rid of all that wastewater. In our case, electricity does all that heavy work, and thanks to the proliferation of solar and wind, electricity is cheap and getting cleaner every day. So it's up to 100 times faster than mechanical means, and anywhere from 20 to 98% cheaper.
How do you get the immense amount of energy, at least that I think in my head that you would need for such a thing, electrical energy, off the grid and into your system to be able to bore these holes?
So yeah, great question. So a typical big tunnel boring machine like Bertha in Seattle or the Big Dig in Boston, whatever, they use what's called a mobile substation, where they bring in like truck skids on trucks, unload them and connect to the grid. And they use typically 5, 10, or 20 megawatts worth of power. 20 megawatts is roughly what is needed for a pretty good size EV charging station, to give you a sense of scale. In our case, for a 2.5 meter diameter tunnel, 8-foot diameter tunnel, we need around 3 megawatts, not 5, 10, or 20. But that's a smaller diameter. And so for a bigger diameter, we're going to be a little bit more in terms of the megawatts, but not crazy in terms of how much power we need. But because we're so much faster, our overall energy consumption or our energy budget is much less.
Now, you get the technology in the ground and it's time to start making holes. You have to have customers for that, right? You talk about taking these kind of overhead power lines that I'm sure you've seen if you've ever driven down the road in your neighborhood, right? And, probably wonder, why is that hanging in the air? That doesn't seem like the best idea. And we're talking about bringing those underground. But What does the trend line look towards? I imagine it's municipalities or energy companies that are looking to bring those underground. How many people are actually looking to push that forward in the years to come?
I should start by saying that in the United States and Canada, it sometimes feels like we're in a third world country. Europe's electric grid, is 80% underground. If you had to guess what the North American grid, what percentage is underground, what would you guess?
I'm going to say 10%.
You're very close. It's about 8%, depending on what study you look at. Now, new lines are often going in underground, particularly in neighborhoods, right? But most of the transmission lines that are going in new are overhead, and that's why it takes 15 years, because nobody wants them. There was a project in Arizona that's like 20 years in now, and it still they haven't even started construction because everybody fights it. By going underground, the levers that NIMBYs and bananas can pull, bananas build absolutely nothing anywhere, nowhere, anytime, or near anyone, and NIMBY's not my backyard. They slow and stop these projects with, small organized groups that are very vocal. But to answer your question, customers, yes, we're working with many, many utilities that want to bury their power lines to make them more resilient, because power goes out every time there's an ice storm, tornado, hurricane. They're causing fires across Canada, Texas, California, Oregon, Washington, and Colorado, Australia. The traffic accidents, squirrels, other wildlife causes these lines to go out. It's just, anyway, so you put lines underground, they're 9 times more reliable, 9 to 15, depending on U.S. utility data. Anyway, so utilities burying power lines is one. Solar and wind developers who have projects they cannot build. Many projects have been stuck for 5 to 7 years because there's not enough transmission capacity. They're like, somebody, please build a new transmission line so we can build our solar farm or build our wind farm. Anyway, so they're coming to us saying, hey, can you put an underground line from your solar farm to a data center over here or a factory over there? So that would be kind of our second use case. And then the third use case would be data centers directly. They're saying, hey, we need power. We can't get it for the, AI and everything else that's happening. There's a huge amount of power demand. And so they're coming to us and say, hey, find a solar or wind developer somewhere and bring their power to our site. And then I guess the last customer class would just be construction companies that are putting in new water lines, wastewater, sewer, fiber, natural gas, power, whatever.
What does regulatory approval look like for something like this to be able to be allowed to bore these holes in the ground? And does that vary by state? How does that work?
Yeah, so it depends on our customer. If it's a utility, they already get the permission themselves, right? Because utilities get, basically near guaranteed access to put their lines along public roadways, the public rights of way. EarthGrid has actually borrowed a page from their playbook, and we have become an approved regulated telecommunications utility. It's like AT&T or Verizon. We're approved in 46 states. That represents 97% of the U.S. population and GDP. So that gives us, again, that near guaranteed access. There's still a process you have to go through, and that process can take anywhere from a few minutes in some rural counties to, over the counter to get the permission to a year or so in states like Maryland and California and New York.
You've been around for a bit. You've raised a ton of money, institutional backing. I believe you put in some good money yourself, millions and millions of dollars to develop this kind of deep technology, something we haven't really seen before. The concern with making an investment in these types of companies, right, is always, are you going to just keep going down this path of R&D, and when do you actually get to monetization when you start throwing off cash? So in terms of commercialization, where are we in that life cycle? When are you going to start putting machines in the ground and really working towards generating revenues?
Yeah, I'll answer it very briefly. We started making money with our first machine last fall, made almost $500,000. We're now upgrading that machine and building a second machine, and we hope to deploy both of them and make well over $1 million this year, mostly this fall. And we have over $10 million for next year already on the books that, some of those projects might be delayed a bit. And then our sales pipeline is over $4 billion. But you're right, it's hard tech, it's deep tech, it takes a while.
In terms of lessons learned now that you're actually in the ground and working with some live clients, can you talk about some of the challenges you faced that you hadn't expected and some of the things you guys are learning along the way?
Yeah, well, we made a big mistake in that we invited a very large construction company to come see our first machine last year. And we had given ourselves a deadline to get it ready for their demo. They had 10 people flying out to see a live demonstration of the technology. And so we were like, okay, yeah, we'll make sure we're ready 2 or 3 weeks ahead and have time for testing and this and that. And then all kinds of stuff happened. Half the company came down with COVID, couldn't work. We had supply chain delays. We had a variety of other things. We're a scrappy company. We literally couldn't find any really thick power cable to send power from one thing to another. So we literally found some scrap in Los Angeles. We drove one of our guys all the way from San Francisco to LA to pick it up. Anyway, so when they showed up, we weren't ready. We did the demo, but we hadn't tested it. We'd only tested it half an hour the night before was when it was finally ready. And so it wasn't as effective of a demonstration as we had hoped. And so it took a while to kind of rebuild their enthusiasm. And they're like, okay, well, yeah, I see you turned it on and you went through rock a little bit, but it didn't really look that fast or that exciting. And now it's very exciting. Anyway, so the lesson learned there is test before you ever bring an outside customer in.
And then in terms of, capital expenditure to build one of these machines, and then what is your thought on almost lifetime value of the machine, I guess, right? How long can it run before you kind of have to replace it?
Yeah, that's a good question. We went and actually inspected machines that are used for trenching in rock. It's basically, think of a huge chainsaw with, the arm of the chainsaw or the blade as long as a F-350 pickup truck, right? It's enormous. And they have teeth on them, and they cut through, limestone and kind of soft rock. They can't get through hard rock or even some medium rock. Most of that, and that company's based in Texas, most of their machines were built in the 1970s and 80s, and they're using mechanical force, but they're still around. They have to do constant maintenance, replacing the teeth and all kinds of things. So we're like, okay, well, if we maintain our machines, we're non-contact. Nothing's really touching the rock. We have to replace the copper electrodes every 300 hours. No big deal. $4,000 for a new one, takes 5 minutes to replace it. So we feel like they'll last for decades with regular maintenance. CapEx, to answer your question, we have 2 machines. We have a tunneling machine, which is going to be anywhere from 8 to 20 million, depending on the diameter of the tunnel and how many plasma torches we have to put on there. And then the trenching machine, like a 2-torch trenching machine that can dig ditches in hard rock or carve out caves or caverns for like a subway station or whatever. Those are anywhere from 2.5 to 5 million, depending on the power of the machine. So that's the CapEx, and it takes us about a year from the time we place an order for all of the parts to get all the parts in and manufacture them here in Richmond, California.
in terms of bringing on new machines to execute on that 10 million plus in the pipeline and dollars coming down the pipe, how many machines are you going to need in market to be able to kind of support the capacity of your demand?
Yeah, that's true. I didn't answer that part of your question. The trenching machine, we think it can generate 3 to 5 million a year, so it's a 1-year payback for those machines. And the tunneling machines depends on the diameter and the project, but we think those can generate 10 to 30 million a year. Again, a 1-year payback. And with the 2 machines we have, we can execute on all the contracts that we're looking at now, for the most part. Although there's some pending contracts and negotiations that would require us to build a lot more machines. So hopefully we get those contracts signed, and then hopefully we can raise some non-dilutive equipment financing and contract finance capital to procure all the equipment we need to build more machines.
And then in terms of, kind of reliability of the equipment so far, what have you seen? What are you excited about? And are there any concerns about, this is a wholly new device, right? That's never been in market. What are some of the challenges you're seeing on that front as you go into the ground?
A lot of challenges, and I'm sure there's some unknown unknowns that things will go wrong. But we just solved earlier this year, actually like 2 months ago, we just solved the biggest known unknown, which is if there's 2 torches side by side, do they help each other? I call it a synergy bonus. Is 1 + 1 torch, is it 2 or is it 2.2 or 2.5? And now that we've been testing with multiple torches, we have a 2-torch trencher and a 3-torch tunneler, and we're growing that to a 6-torch tunneler. Anyway, the synergy bonus is 2.5 or better, and so that's exciting. Another big challenge we had is spoils removal. So in 2017, when we built the first prototype, and by the way, you mentioned I put in a bunch of money, and I did. I bootstrapped the company for the first 5 years, and we de-risked a lot of technology, and sorry about that, a lot of the technology, a lot of the subsystems. The biggest challenge is spoils removal, getting the stuff out. You can line the tunnel with normal techniques, concrete, shotcrete, spraying arms, and things like that, but spoils removal. So when we're in a high silica rock like sandstone, some granite, some basalt, there's silica, so it melts, and we create man-made lava. And magma is not easy to remove. So we're like, oh, well, let's just use a vacuum. So we went over to Home Depot in 2018, got 6 big shop vacs, and started sucking out the vacuum, and it worked great for about 2 seconds, and then everything melted. Anyway, and so we've had to go to a very powerful industrial mining vacuum with water-cooled sleeves on the inlets, and it basically sucks that magma out and turns it into silica sand, which, by the way, we can sell for concrete manufacturing. It's quite valuable. So that took a while to perfect that process. That's one example.
Then in thinking about, again, this type of device over what's been traditionally in market, from a cost perspective, I'd love to understand kind of cost to use this type of equipment, equal size holes that you're trying to dig, one with original equipment, one with yours. Does the cost go down, or is there a premium because you're doing it faster and more efficiently?
At the moment, we're offering, a discount to folks. We're even, saying, hey, we'll do it at cost plus, just because we want more experience out in the field. We've only completed 3 projects out in the field thus far. So, but I'll give you an example. For a 2.5 meter diameter tunnel, I do everything in metrics. The U.S. is literally the only country on the planet that's still using the old British feet and pounds and all that nonsense. But anyway, so 2.5 meters diameter, for those who can't translate, that's 8 feet. So pretty big, you can walk around in it. That'd be the size of like a stormwater tunnel, or a big tunnel where utilities want to have their crew or their technicians go into the tunnel to service the lines, visually inspect them, things like that. So that size tunnel is quite useful for a lot of things. Typically, the cost per kilometer is about $5 to $7 million per kilometer. Our cost is less than $1 million per kilometer. Wow. For a concrete lined tunnel.
And earlier you had said that, the boring company right there hoping to get to a snail's pace, to be able to chip through at a snail's pace. What's your rate?
Yeah, so it depends on the geology. Obviously, we're faster in soil and soft rock. In some of the hardest rock that we've tested, basalt, we're anywhere from 80 meters to 600 meters per day. The world record in basalt is like 7 meters in a day. So we're anywhere from 10 to, anyway. So we think we can go up to 1 kilometer per day, 1,000 meters, in most geologies if we have all of our subsystems operating in a tunnel. In a trench, it's much slower because we lose the heat. If you're digging a ditch, we lose all of our heat to the air. Not all of it, but a lot of it.
Help us understand what kind of the magnitude of these projects is, and I know you're talking in kilometers. Are these, 5-10 kilometer type projects? Is most of this stuff kind of local, regional, power lines that you're going through small neighborhoods? What does that look like?
Yeah, it's all over the map. First project we did of any length was 2 kilometers long. It was a trench for power and fiber conduits. We have just put in a bid for a 420 kilometer long project. Another one is 110 kilometers, about 68 miles, from a data center to a solar farm. And then we're negotiating a contract for multiple very long tunnels connecting San Francisco to LA, LA to Phoenix, Phoenix to Houston, and then San Francisco all the way to the East Coast, to New York City, to be able to move large quantities of energy back and forth across the 3 grids for the first time in our country's history. So that's a big infrastructure fund that's negotiating that deal with us. So fingers crossed.
The question I have for you is to help us kind of understand the scope and size of the market opportunity. What does that look like? And then the second thing I'm curious about is, are there any exits, IPOs, or companies with public valuations that are kind of in the boring tunnel space to help us understand, how big this company can be?
Yeah, that's a good question. I'll start with the second part. There are a bunch of big construction companies out there. There aren't really any publicly traded tunneling companies. There's some manufacturers of tunneling equipment, and then there's construction companies that buy that equipment and use it. But a vertically integrated company like ours, the closest parallel would be companies like American Tower, Crown Castle, Kinder Morgan, and Williams Pipeline. And so if you look at, and we've used those as comps for us, and so based on that, we're talking to some big Wall Street investment banks that want to take EarthGrid public in 2026, maybe 27. And they think that based on, even with, minimal execution on our pipeline, we, by the way, have a $4.4 billion sales pipeline of projects that are in our queue, right? 10 million for next year, but huge amount of projects that we're talking to people about in potential contracts. Anyway, they want to take us public at 3 to 6 billion, which would be like a 40x return on our current valuation.
What are your thoughts in terms of number of machines you have to develop and how much outside capital you might need?
Yeah, we if we land, say, 20% of the pipeline that we're working on right now, we're going to need to build about a dozen more machines. So you can do the math on that, call them 10 million each, 120 million. We think we can raise the vast majority of that capital with non-dilutive equipment financing from Bank of America and others like that, as well as contract finance. And then the other thing to keep in mind is some of our project, we have 2 products. We're not selling our machines, by the way. Our products are Boom and Badass. Got to have a sense of humor. So Boom stands for Build, Own, Operate, and Maintain. Badass stands for Boring and Drilling as a Simple Service, or BAS, Boring as a Service, if you'd like. And so think of us like an underground real estate development company. A real estate developer builds a building, they get permitted, they build it. Might take a couple of years, but they do it, and then either they retain ownership and lease it out, make money for decades, or they sell it for a profit. We're going to do the same thing. We're going to dig a ditch, dig a tunnel. We'll either lease out space inside or charge a toll on all the commodities flowing through. That's our Boom model. Or Badass will dig it and sell it. In the Boom model, let's say we get a 25-year contract from a solar farm to move power from their solar farm to a data center. And it could be either the solar farm company or the data center that signs that contract. As long as it's creditworthy, we can then go to the project finance lenders out there and raise a construction loan to build that project. Because think about it, on the Boom project, we don't make any revenue at all until the project is fully completed and we're starting to earn lease payments or tolling payments. So there's no revenue. But if it's an investment grade contract, like I said, we can go get that loan, build it, and then the interest payments are all deferred until the project is placed in service. And then again, it has to be a very creditworthy customer. So that is a way for us to raise a lot of capital to complete these infrastructure projects, doing the same thing I've been doing for 30 years.
Incredible. Troy, thank you so much for your insights here today. For those who are on the line, I'll give you the last word. What would you say to them?
There's a lot of reason to hope. Infrastructure in this country has been rated a D, D minus, C plus, C minus over the last several decades. It's pretty bad, but not just EarthGrid, but there's other companies out there that are going to upgrade our infrastructure. Will accelerate the clean power revolution because solar and wind power are far cheaper than anything else. So it's happening, and it's going to happen, and it's going to accelerate, and that'll I think, give all of us hope. And upgrading our infrastructure is one issue where, regardless of your political affiliation, I think we can all agree that we need to upgrade our infrastructure in this country to make our nation and our economy stronger.
If you like what you heard on the show today, you can check out why EarthGrid scored a 4.8 out of 5 at kingscrowd.com and received an investment from Kingscrowd Capital. You can now invest on net capital until September 27th, 2024. And please like, subscribe, and share our podcast wherever you listen to podcasts so more listeners like you can find us. Thanks for listening.